Okay, so this is going to be our test 2 review. There's going to be a lot of formulas that you're going to need for this test 2. I'm going to write them down as I go. The online test is similar to this one, but it's going to be more like your MyMathLab problems and not multiple choice. So as always, I recommend taking the paper test if at all possible, because the paper test is easier. Okay, so let's get started. There's 25 problems. There's a few from each section, so find the distance between point 1 and point 2. So distance equals x2 subtract x1 squared plus y2 subtract y1 squared. I should use a pencil while I'm doing this, but let's live life on the edge. So this point right here, our x value is 4, and our y value is -1. This point here, our x value is -2, and our y value is -3. So once we have those 2 points, go ahead and decide which one's point 1 and point 2. So we'll say this one is x1 and y1, and this one can be our x2 and y2. Then we'd substitute them into the equation formula. So x2 is -2 subtract x1, which is +4, squared plus y2 -3 subtract y1, which is -1 squared. So I'm going to go ahead and simplify. So I'd have -2 subtract 4, didn't do anything there, squared, plus the -3 subtract a negative would be +1 squared. So we're going to have -6 squared plus -2 squared, which would be 36 plus 4. Be sure if you are doing this on a calculator, you put your parentheses around those negatives. Otherwise, it's going to say that there's no solution, because a negative not in that parenthesis would still be negative. So use your parentheses if you're using your calculator. So right here we'd have the square root of 40, and they're going to have you rationalize, simplify this. So we have the square root of 4 times the square root of 10. The square root of 4 is 2, so this would be 2 square root of 10. Find the distance between point 1 and point 2. So I'm going to write the formula down again. Remember, if you come and take this test on paper, that you show your work so I can give you partial credit. If you take it online and you want partial credit, show your work, number them, and then take a picture and email them to me when you're finished so that I can review them. Okay. And point 1 can be -5, -5. So this is x1 and y1. And point 2 is -5, -3. Blend that in, x2 and y2. So we have -5 subtract a -5 squared plus -3 subtract a -5 squared. -5 subtract -5 is 0. So so I'd have -3 plus 5 squared, which would give me the square root of 2 squared. These would cancel out, but we'd have square root of 4, which is 2, if we didn't cancel it out. So find the midpoint of the line segment joining the points P1 and P2. So our midpoint formula, you take your x values and you add them together and divide by 2. Then we take our y values, and we add them together and divide by 2. So you're averaging your x and y values. That. All right, so right here we'd have 9 plus 2 divided by 2. And these are our x values. So I'd have 11 over 2. And that doesn't simplify, so this would be my x value. There's only one of them. So it's this one. If we wanted to go ahead and do our y values, we'd have 9 plus 1, not 9 plus 1, 8 plus 1 over 2, which would be 9 over 2. Okay, 4, we'd have 7 plus a negative 16 over 2, which would be a negative 9 over 2. And these were our x values. And then our y values would be 1 plus a negative 16 over 2, which would give us negative 15 over 2. So our point would be negative 9 over 2, negative 15 over 2. Determine whether the given equation is on the graph of the equation. So this, determine whether the given point is on the graph of the equation. I said the given equation. X and y, so we substitute in. So we'd have 4 squared, subtract our y value is 0 squared equals 16. So I'd have 16 subtract 0 equals 16. 16 equals 16. That's true. So yes, that point is on that line, or it's actually a circle. Okay. Graph the equation by plotting the points. So I'm going to go on a tangent real quick. So we have y equals mx plus b, where b is our y-intercept, and m is our slope. And it is in the slope-intercept form of a line. So our y-intercept is 6, and if we wanted to put that as an ordered pair, it'd be that. And our slope is 3, which is going to be 3 over 1, which I'd say we'd go up 3 because it's positive. Always go right. So we're looking for this point first. So 0, 6. This one's y-intercept is negative 2. This one's y-intercept is negative 6. This one's y-intercept is negative 6 as well. And this one's y-intercept is positive 6. So I guess really on this one, you only have to find that y-intercept. And then if I wanted to graph my slope from this point, I'd go 1, 2, 3, and write 1. That point is on there. So D is my graph. List the intercepts of the graph. So our x value here, because intercepts is just where does it cross an axis. So we have the x-axis and the y-axis. So we have 1, 2, and 3 intercepts. So this one right here, our x value is negative pi over 2. The y value is 0. For it to be an intercept, one of the values have to be 0. Right here, our x value is 0. Our y value is 3. And then this one, our x value is pi over 2. Our y value is 0. And then we find the one that has that. So we have negative pi over 2. And this is 0 first, so that would be it. And then pay attention if you're doing it on paper. This one is another x-intercept, and this is our y-intercept. Okay. Big thing on this one. The origin isn't an intercept. The origin is not an intercept. So we have 1, 2, 3, 4. And this one has the origin. This point right here is 4, 0. This one is 0, 4. This is negative 4, 0. And this one is 0, negative 4. List the intercepts of the graph. Tell whether the graph is symmetric with respect to the x-axis, y-axis, origin, or none of these listed. So where does it cross an axis? There's 2 points. This one would be 0, 6, and this one would be 0, negative 6. So it's not this one, and it's not this one. Now then, the difference in these two are x-axis, y-axis, origin, and origin. So this will make more sense when we do this one. But when we flip this graph across the x-axis, it lines up. So we have symmetry with the x-axis. When we fold this graph along the y-axis, it lines up. So it has symmetry with the y-axis. We take this graph and we rotate it 180 degrees about the origin. It lines up. So it has symmetry with the origin as well. So this is correct, but this one is the correct answer because it's symmetric to all of them. Okay, and this is where it'll make more sense, except that they're not all on the same graph, and that annoys me. So we're looking for the one, complete the graph so that it has the given type of symmetry, and the symmetry we're looking for is the origin. So this one has symmetry about the y-axis, because if I folded this one along the y-axis, it would line up. So this one is, I'm just going to write y-axis on it. I'm going to abbreviate symmetry. This one would line up if we folded it across the x-axis. So this one is symmetric to the x-axis. This one has no symmetry. This one was shifted. And this one is symmetric to the origin, because if I rotated this 180 degrees, these two would line up. And it's on the other page over there. Okay. Slope time. Find the slope of the line. So there's two ways you can do this. You can use the graph and visualize it. So I know this graph right here has a negative slope because it's going down from left to right. So I know it's not this one or this one. And then I see it goes over 2 and down 5. 1, 2, 3, 4, 5. So I know that it's negative 2/5 by looking at it. I wrote that backwards. Slope is rise over run. So our rise from this point to this point, it goes down. So this is -5 and this is 2. So y over x, so we'd have -5 over 2. Getting ahead of myself. Okay. The other way to do this, slope is y2 subtract y1, x2 subtract x1. This point right here is -5, +1. This point right here is -3, -4. So we can do -4 subtract 1. over -3 subtract -5. So we'll rewrite this real quick so that I can put +5 because you can't subtract a negative. And then we'd have -5, -3 plus 5 would be 2. But that's what you're going to use on these right here. Slope equals y2 subtract y1 over x2 subtract x1. And I'm going to write above it that slope is m. So we're going to have, go ahead and label them. You don't have to, but I've never seen, or I see less mistakes when people do label them rather than when they do not. So we have 9 subtract -9 over x2 -7 subtract 4. This would be 9 plus 9, which would give us 18. -7 subtract 4 would be a -11. So we're going to have -18 over 11. Okay. Then here we'd have 5 subtract -3, and I'll label over 1 subtract -4. So I'd have 5 plus 3 over 1 plus 4, which would give me 8 over 5. That doesn't reduce. Yay. Okay, this one's also not on the same page. So we're looking for the point -3, -8, and the slope -1. So first, find that point. So is it on the back? Nope, this will work. Okay. So -3, -8. -3, -8. Good with that one. This one would also be -3, -8. But these have +3, -8. So C and D are out. But the big difference on A and B is one has a positive slope and one has a negative slope. So this one, since from left to right it goes up, our slope is positive. Here it goes down from left to right, just like we're reading. So if we followed this, we'd be heading down. So this one has that -1 slope. A vertical line containing the point 4, -10. So vertical line is going to be x equals. Vertical lines have undefined slope. So it's just x equals, and it's going to be x equals the x value. So our x value is 4, so it's x equals 4. The other way to think about this one is if we had a graph, and we're going to pretend. So we'd have our +4 and -10 somewhere down here. And if we drew a vertical line here, the only thing that stays the same this entire time is that our x value is 4. Find an equation for the line in the indicated form with the given properties. So we're containing the points -2 and 8, -8, -7. And they want us to write this in slope-intercept form. So This is our end goal. So the first thing we need is slope. So m equals y2 subtract y1 over x2 subtract x1. So I have negative 7 subtract 8 over negative 8 subtract negative 2. That would give me a negative 15 on the top. That would be negative 8 plus 2, which would give us a negative 6. Negative divided by negative is positive. This also reduces by 3. Make note. Reduces by 3. So 3 goes into 15 5 times. 3 goes into 6 2 times. So our slope is positive 5 halves. Then second pick point. I'm going to use negative 2, 8. And we need to use point slope form, which is y subtract y1 equals m times x subtract x1. So y subtract our y value equals our slope times x subtract our x value. So I'd have y subtract 8 equals 5 halves x plus 2. Distribute 5 halves x. 5 times 2 is 10. This reduces, so I'd have y subtract 8 equals 5 halves x plus 5. And then I would add my 8. 8, 9, 10, 11, 12, 13. Now, if you're doing this on the paper test, first thing I would have done is if my slope was 5 halves, I know that. I know I'm supposed to go to slope intercept form. M wouldn't be there. This isn't slope intercept form. So I'd be torn between these two, and my slope was positive 5 halves. So once I found my slope, if I was taking the multiple choice test, I could narrow it down and be done. All right, find the slope intercept form of the equation of the line with the given properties. So we're going to have to use point slope form again. And I'm not going to write slope, I'm going to write 3 right on this. And our point is negative 2, negative 3, and we're going to use y subtract y1 equals m times x subtract x1. So our y1, y subtract negative 3 equals our slope, which is 3, times x subtract x1. So I'd have y plus 3 equals 3 times x plus 2. We'll distribute by 3 and then subtract that 3. Lots of 3's. Y equals 3x plus 3. As soon as they give you that slope, though, anything that's negative isn't an answer if our slope is negative. They gave us slope. Our slope's not going to change if they give it to us. 18. Find the slope and y-intercept of the line. So on these, solve for y. So this first one, if we had x plus y equals 11, I would subtract my x. Remember, these don't combine, so I'd have y equals negative x plus 11. My slope is here, so slope equals negative 1. This is my y-intercept, so y-intercept equals 11. So I'd have negative 1 and positive 11. 19. We have 6x plus 7y equals 15. Solve for y first. So we're going to subtract 6x. Remember, you cannot combine those. They're not the same thing. So I have negative 6x plus 15. Divide by 7. So y equals negative 6/7 x plus 15 over 7. Whatever is with x is our slope. And then our y-intercept is what's at the back. So we have negative 6/7 and a positive 15/7. Parallel to the line y equals negative 2x containing the points 3, 8. So parallel, where do I want to write this? Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal slopes. I feel like I spelled reciprocal wrong. I think there's another I in there somewhere. It'll be all right. So this one right here, I know that my slope is the same as this line. So my slope is negative 2. And the point I need is 3, 8. Making notes for y'all if anyone follows along on these. Okay. So we're going to have our slope is negative 2 and our point is 3, 8, and we're going to plug it into point slope form. So we're going to have y subtract 8 equals negative 2 times x subtract 3. Make sure I wasn't missing any negatives. So we have y subtract 8 equals negative 2x. A negative times negative is positive. And we add our 8. Negative 2x plus 14. Y equals negative 2x plus 14. Okay, our perpendicular to the line y equals 2x subtract 2. Opposite reciprocal slopes. That's usually all you need for this, but we'll work it out all the way because if you're taking it online, you're not going to be able to do this. Okay. So if the slope is 2, we'd put it over 1 because it's a whole number. Anything over 1 is still itself. And now the opposite would be a negative, and the reciprocal would flip it. So the opposite reciprocal is a negative 1/2. So this one right here, this slope is the reciprocal. This slope is the opposite because it's just negative. This slope is the same, and this is what we need. Now, if you were working this one out, you'd have to plug it into the point slope formula and then go through it to get your y-intercept, and so it'd be in the right form they want. Okay. Write the standard form of an equation of a circle with the radius r and the center h. Okay, so standard form x subtract h squared plus y subtract k squared equals r squared, where h and k are the center and r is the radius. So on this one right here, remember the sign's going to change. Whatever it is, it's the difference, the opposite. So right here, we're going to have x, and since it's subtract, it'd be subtract -4 squared plus y. Why did I do it like that? Oh, that bothers me so much. So you don't go there. Y subtract 6 squared equals 11 squared. Remember, it's 11 squared. A bunch of people forget that one. So when we simplify this, we'd have x plus 4 squared plus y subtract 6 squared equals 121. Why'd I squish myself right there? I'm sorry. So this one doesn't have it squared. So x plus 4 squared plus y subtract 6 squared equals 121. You just have to remember that it's the opposite of these and to square your radius. But here, I need my center. Opposite. So since it's -5 or subtract 5, it's +5. Since it's +3, it's -3. Okay. And then my radius would be the square root of 9, which is 3. All right, so I'm looking for 5, -3. So this one right here is -5, -3. This one is 5, -3. This one is 5, +3, and this one's -5, +3. So the one we needed was 5, -3, so B is our answer. Variation problems. A varies directly with t squared. So first, direct variation. Would be y equals kx. Inverse would be y equals k divided by x. And they'll give you your variables, but direct is multiplying, inverse is divide. So A varies directly with t squared would be direct. So we're going to have k times t squared. Now solve for k and substitute it back. So A equals, so we have 36 equals k times 3 squared. So 36 equals 9k. Divide by our 9. So 4 equals k. Take this and put it back here. So A equals 4t squared. R varies directly, so R varies directly with G and inversely with the square of H. So we're going to substitute into this and solve for K, so R equals 3. K, G equals 3. We'd have 5 squared. Solve for K. So we'd multiply by 25. Once you solve for K, substitute it back into the original. So we have R equals 25G over H squared. And that is all. I will get this uploaded, and y'all can email me if you have any questions.